am Manyata from ECE, Electronics and Communication Engineering. So I am doing diploma in Electronics and Communication Engineering. So as part of the Embedded Systems and Embedded Systems internship, which has given me an opportunity in the Embedded Systems, uh, Emertxe Technologies, Bangalore. So I have developed an ADAS dashboard using STM32 Bluepill, Pixim Lab, and Python dashboard. So this was my first demo video and my first internship in online. So the project objectives are designing the STM32 using the software tool, and we have monitored the system, and using Pixim Lab also we have saw some of the outputs and read some analog sensors, implemented EV dynamics, and developed ADAS algorithms, and transmit and visualized the UART, and created a live Python dashboard. So these are all the objectives. Electric vehicle and ADAS features. So usually many of us will use the electric vehicles nowadays, and upcoming days the demand for electric vehicles are more. So let us see the features of an electric vehicle. So it has high energy efficiency, low maintenance, and regenerative braking. So these are the features of electric vehicles. And we have the ADAS functions also. So as I mentioned in the PPT, forward collision warning and blind spot detection and parking assistant and overspeed warning. So all the parameters are given here. And the system architecture. So if a EV vehicle or a electric vehicle should run properly, means all these six functions should function properly by coordinating each other. So sensor inputs, ADC conversion, system processing, and EV parameter processing, ADAS decision engine, and alarm, fault, and detection. So all these things should work at a time and with a coordination. So these are the software and hardware tools what we have used during the internship process. So STMcube, ID32, Pixim Lab, Python, Terraterm, VSP, PySerial. So all these things were software tools, and hardware. We have used one STM32 Bluepill ultrasonic sensor, as you know, as all of you know, potentiometers, nothing but voltmeters, and LEDs and buzzers for alarms. So all this stuff, and STM32 Bluepill and GPIO mapping. So the controller is STM32 F103C86, and the system clock was of the frequency 8 megahertz and baud rate of 115200 bits per second, and ADC resolution. Operating voltage was 3.3 volts. Dashboard updates were 100 milliseconds, and the ping configuration, all of you know, a PA0 accelerator pedal, and PA1 brake pedal, PA2 motor system, and PA3 battery SOC, PA9 yacht transmission, PA10 yacht reception. So this is all the stuff what I have learned and identified and explored in the software. I'll show you the software also. Okay. And we have successfully implemented the dashboard simulation using Python visualization, and the collision, blind spot detection, and alarm, fault system, all are fully completed and implemented. So for future scope, this is more highly demanded thing. So all these things. Yeah, okay. Just give me a second. I'll show you the. Yes, okay. I have already opened the software. So, okay. So, EV dash was the project. So, first I have did the LED blinking, and this was EV dash. So, this is a pin configuration of the EV dash. So, as all you know, IC means integrated chip. So it is having all the terminals, input output terminals, gate terminals, all those things. And we have the program here. So main.c. Okay. So here we have the program. I just want to build the program once again. Build the project. Okay. So here it is seeing zero errors and zero warnings. That means this code doesn't having any error or warning. So happily we can check the output at the Pixim lab. Okay. In the Pixim lab, you have to load a binary file. So yes, binary file ev-bin. Uh, .bin is nothing but binary file. It stands for that. Okay, upload it. And after uploading it, we can see the output. Take some time. So okay, I forgot to explain all the things. Okay, I'll explain now. So this is a potentiometer, and these are all the ultrasonic sensors. Frontal ultrasonic sensor, left or right, and this is a virtual term. So this is for acceleration, this is for brake, and this is for temperature, SOC, and this is for temperature. So we can vary all the things, and after double clicking on it, we can get the variation in this. Okay, so this is like this, and I'll show you what inputs we can take, means encoders, game pads, potentiometers, push buttons, switches, ultrasonics, and in the output 7 segment displays, buzzers, LCDs, and RGB LEDs, all these things. And in the virtual term, we will have text box, VCD play, and IO terminals. Okay, this is all about the demo video or the document. I have learned a lot from Emertxe. So thank you, Emertxe, for giving such a wonderful opportunity. This platform is very good and well for students who are interested, and so who are interested and wanted to do anything in the electronics, means you can join in Emertxe. And in this Emertxe we have a very good scope for future. The mentors were so interactive, and they are all very well treated, and they'll teach very nice. So thank you, Emertxe.